So I am about to replace this piece, not that one, but the three capacitors, these resistors, and the bridge rectifiers that are under here. So that I have done myself, I made myself, completely myself, this power supply. So we can easily understand what this is, because this is one rectifier, another rectifier, another rectifier, three rectifiers. These diodes are an overkill here, but I had them spare from other boards that I salvaged them. These ones are more normal for this, because this does not get many amperes, so we don't need that big diodes. And here we have 3, 6, 9 capacitors, and they are all here: 1, 2, 3, 4, 5, 6, 7, 8, 9. Just to mention that for this capacitor, which here is 50 microfarad, I put 68 microfarads for this, and because the voltage on this area, only for the first capacitor, if you see here, only for the first capacitor the voltage is above 250 volts, but all the rest are not above 250 volts. So these capacitors here are for 250 volts, but this one is for 400. That's why it's so big. I couldn't find here readily available capacitors for 50 microfarad and more than 250, so I bought this, which is 68 microfarad 400. That's why it's bigger, but it's no big deal, because you see, this is not high at all. It will still have a lot of spare room. I think I will take this and put it here in the front, like that, looking upwards, as it will be like that. That's what I think of doing, but I will see. There I have a couple connections. I could do this differently, I know, because due to my lack of experience, I did mistakes. For example, I should put diodes on two different lanes for plus and minus, so I have one lane for minus altogether, and I didn't do that. So I had then to bridge every ground part of this to another lane to have them all connected. Anyway, all the capacitors have one lane which is here, which is all for the ground, and the other, the plus parts of the capacitors are in different areas here. That's how I designed it. I hope it works. Now let's proceed by taking out this one. So now we have this part loose, as you can see. To do this, we have to take out the last valve from here, and take out two screws that are underneath that hold this thing here. Then we have to separate the two chassis and put some distances here and here. I have showed other videos while I do this, so look at my other videos how to separate the two chassis and lift them like that. Generally is 1, 2, 3, 4 screws, and you have to undo two screws here back that hold the two switches here, so that the mechanism gets down and gives you room to lift it more. So now I have to undo this part here and separate it from the power supply, and I can see that this is here hard connected, so I will have to find a way to do this. I don't know how easy this will be, and I hope I don't do any damage. Okay, you see, I have to bend in this part here and this part here for this to get in and give me access to take it out. I will not do this on camera because it will take some time, I think. So I will stop the video now. So I left the video running just to show you how many various methods that I used, in case that might help you in any way. Anyway, this is finally out here from both sides, as you can see. Now I will have to unsolder all external cables. I have taken my notes here on what I should unsolder and all the colors and where each one goes. So I will start right now. So, two gray cables here, one white cable here, this gray cable goes to number 4 here, 1 2 3 4. So this one I will have to take out also. Okay, it came out with the red cable from the bridge rectifier, but now I separate. But this I have put it in my power supply. There is a purple that goes to a bridge rectifier, so I will leave it there. And next capacitor, I will have to desolder a yellow cable. No, the second is okay. I will have to desolder a red cable that is here because it goes there at the back. So it is out. Now I will have to desolder a green cable from the second capacitor here. Okay, all these cables will have to be resoldered, and I have from the third capacitor 2 orange ones. One. Two. And from the third capacitor I have a yellow out, a green from the second, it's out, and a blue from the third. Well, all power supplies, let's see if I have, there is a white cable that is ground. I have to note down. So there is a white cable that will have to be soldered on the ground. There it is, and it goes to the back. Now, looks like, and I will have to desolder this resistor. I will write it down here. That goes to number 10 above. Okay, this resistor is desoldered also. There is a ground here. Okay. Desoldered. So this one is supposed now to be free. And what I still have to desolder, let me put my soldering iron here, right? So all this is out. Is it? Yes. And what I still have to desolder, so there is a brown that has to be disconnected from a red here. It is. So all this is free now, except that the cables directly from the transformer that go to the power supply of the rectifiers. So let's get them out. Also this, it's there's a yellow out, there is a okay. Here we are again. I disconnected the two alternating currents, the two cables for the alternating current for the first rectifier, which is here, which is one is yellow, the other is brown, not black, but I did not disconnect it. I will disconnect it right now. I will have to go from the other side because it's connected strangely. Let's see. Sorry. Okay, first rectifier disconnected. Let's disconnect. I keep losing my stuff, although I leave them all around me all the time. I always search for them. Now I'm looking for anyway. So, power supply of the second rectifier, it's blue and it's out, and at the back it's a white cable attached to a red cable. Maybe somebody did this sometime in the past, I don't know, but it's back here. Okay, this is out, and last are the two cables red and green that I soldered yesterday to show my video of how to replace one selenium bridge rectifier. This time I will take it back out and one is white and the other is green, and it's here. The heat shrinking tubes that I installed now don't leave me to unsolder this easily. Okay. Now I hope the whole power supply is free and I can take it out. Is there anything I forgot? No. Here it is. 50, 50, 50, 50, 50, 50. And this, I can't see, it should be 600, 600, 600. So this is what I'm taking out, and this is what I'm putting in. The size is extremely different. Okay, so now I will clean a little bit here the area, and I will start think how I will attach this here. Maybe I will put 1, 2, 3, 4 extra screws, or I will use this part here, or put new screws. I think I will put 2 new screws, very small screws at the back, so that I am more secured. But that's it, I will stop now. Well, this is hard for me to do. Sorry, dear G36, for being so violent. But I have to secure my power supply somehow. Oh. Oof. And I thought it just went through, but I just... Okay, here now it's full of steel particles, so I will have to clean this very carefully. Steel particles are a bad thing no matter what. I think I will have to bring a better that. So let's see if this does a better job. I hope. Okay. Oh. Yeah. Okay. So this is cut. So the back side is a little bit rough, but anyway. Nice handy thing. Okay, I guess everything is cleaned. So I took some time and installed some heat shrink tubes on the alternating current cables. You see, there is one pair here, the other pair is these two here, and the last pair is these two here. So as you can see, for example, here I put heat shrink tubes so that I can secure them easier later. But it's time to now solder them to the board. I will try and test the voltages later after I put the power in, but not the power out, and measure the voltages on this side and see if I get correct voltages or if I blow some fuse or something. But this is risky because now that there will be no load, this capacitor, which is 400 volts, it's okay, but the second one, this one, through this resistor will also get 260 volts, although it's 250 volts rated. So only this capacitor is risky because this is not connected to that. So I feel a little bit worried that I damaged this, but anyway, it's really close and I hope there won't be any problem. So let's start soldering the power cables. What would be the best position to put this? I don't know. No, I have to secure this somehow there because it slips away. this should stay like that somehow. I have to find a way to keep it like that. So this is much better, and I lifted the chassis to have more room here to work on. So now I think my life will be easier. First, second is not long enough. Yes. Wait a minute. I will first secure this a little bit. Okay, now I have much more room to work on. And of course, I found it. But we'll need some solder more. This is a demanding job, really it is. Second cable done. So the cable from the third diode, it's too short indeed, and I will have to enlarge it a little bit. So this is how it is. Eventually soldering the alternating current wires gave me a hard time, and makes me think if I would do this, if I knew it, maybe I would just replace the bridge rectifiers and forget about it. Anyway, let's see. Down there, one bridge rectifier connected here and here on the first and on the third. Okay, the second bridge rectifier is connected here and here. This cable gave me a hard time because if you see here this connection, the original wire which is in here is this enameled wire coming from the transformer, and it was too short and I could not solder an extension to it because it would break. I would just took some out, it would break, then took some more, and at the end it gave me a really hard time. And the last alternated current is this cable and this cable. Okay, so I will just try and place the heat shrinking tubes that I have here, I have for the others also, so that they are secured, and I will keep on with it. So now that the alternating current side is connected, I will turn on the transformer and see what voltages I have. So far so good. 100. So ground is here, and this is 29. This is 325. It is too much indeed. So the voltage without load is high. I knew this would be the case, but the thing is that I wanted to see if everything is connected correctly. So if I see DC voltage, it means that it's connected correctly. I have to check the other line, which I don't know where it goes. The other line is the, I have the 24 and the 27. There would be the other line. $32, $29, $324. I'm so worried doing this that something will just pop. So looks like I have connected correctly the alternated current side. Now I have to search for this. So as this will stay there, something like this there, that I want it to be secured somewhere here. So I will have to make some 3D printing from these bolts to go up and have some holes and keep this here. So I have to design this and bring it here before I secure all these things together. Now that the alternating current of this side there is connected, I can just screw this in place. I don't think I can do any more. This was very demanding for me to solder the alternated current side. So I think I will leave it for today.